Bismillahirrahmanirrahim. In this video, we are going to discuss the Laplace transform. The Laplace transform of a function f of t. Okay, if f of t is defined on for t greater or equal to 0, then the Laplace transform of f of t is defined as Laplace of f of t is equal to integral 0 to infinity e minus st f of t dt. This will be the Laplace transform of f of t if this integral exists. So let's do some for some simple function, the Laplace transform. Let f of t is equal to 1. So what will be the Laplace transform of 1? That is equal to e minus st 1 dt. That is simply, and the integral goes from 0 to infinity. Okay, this is simply integral from 0 to infinity e minus st dt. That is equal to e minus st divided by minus s, and integral limits are 0 to infinity. So the Laplace transform of 1, this is 1, is equal to, when I put infinity, I will get 0, and minus, if I put 1 or 0, then exponential of 0 is 1 divided by minus s, and I get 1 over s. So Laplace transform of 1 is 1 over s. Let's try the Laplace transform. Take f of t to be t. So then the Laplace transform of t is equal to integral 0 to infinity e minus st and t dt. Integration by part. So integrating the exponential, I will get minus e minus st over s and t, and we have to take the limit 0 to infinity, and minus integral 0 to infinity minus e minus st over s dt. That is integration by differentiation, taking the differential of t in this integral. Okay, this is goes to 0 because on upper limit this is 0 and on lower limit t is 0. So overall I get 0 from here, and this minus will become plus. So this implies Laplace of t is equal to 1 over s integral e minus st dt, but we know that this is the Laplace transform of 1. So that means 1 over s and Laplace transform of 1 is 1 over s. So again multiply by 1 over s, and that is equal to 1 over s square. So the Laplace transform of t is equal to 1 over s square. Okay. So we can see, okay, let calculate another Laplace transform. Call it 1. This is equation 1. This is equation 2. And let's take f of t to be t square. So take the Laplace transform of t square, that is integral from 0 to infinity e minus st over t square dt. That is equal to integration by part e minus st minus is integrating the exponential, leaving the other from 0 to infinity, and then minus integral 0 to infinity e with a negative sign minus st divided by s and 2t dt, differential of this function. This is 0 because from upper limit the exponential is 0, and from lower limit t square is 0. So overall I get 0, and this implies Laplace transform of t square is equal to 1 over s integral. Okay, the 2 is out. This 2 is here. Now 0 to infinity e power minus st t dt. But we know that this is the Laplace transform of t. So the Laplace transform of t, we know its value from the previous slides. This is 2 over s, and the Laplace transform of t is 1 over s square, and this is overall 2 by s cube. So this is equation 3. Looking at equation 1, 2, 3, we have a pattern for the polynomial. A pattern for the polynomial is this. Laplace transform of Tn should be n pictorial divided by s n plus 1. So clearly this is Laplace transform of, if n is 2, this is 2 pictorial divided by s2 plus 1. So this is okay. So if we use Laplace transform, we need, let's say, t to the power 3, the Laplace transform. This will be simply 3 pictorial divided by t4. That is 6 by t4. And let's say Laplace transform of T10, that is 10 pictorial over S11 and so on. So the we, we learn simple formula for polynomial power. This is integer power, is not fractional power now. Fractional power will be done in other videos. So if we have polynomial power, then we can simply do this procedure and it is very easy to do. Okay, thank you.